Okay, in this video, we are going to look at solving inequalities. Now, the great news here is you have already learned how to solve an equation, and an inequality is just like an equation with one new rule. And that rule is when we multiply or divide each side of an inequality by the same negative. I'm going to say that again. When we as mathematicians ask a problem to multiply or divide by a negative, we simply reverse the inequality symbol. So like in the last video when we talked about if we have 4 is less than x, well, I need to reverse the symbol when I'm flipping things around. So if I said x would be greater than 4, sort of the same concept. When we flip things or we change things like that, we need to take into account that that symbol needs to be reversed to remain true, right? 4 less than x is the same thing as x is greater than 4. So looking here, on number 1, I have y plus 8 is less than or equal to 5. Solving for y plus 8, I'm going to move that 8 by subtracting the 8 from both sides. The y is going to come straight down, so y 8 minus 8 is 0, so we put a line through that. I'm bringing the symbol straight down, just like with an equation. 5 subtract 8, negative 3. Now in this problem, it worked just like an equation, because I never multiplied or divided, and I definitely didn't multiply or divide by a negative number. So again, just like equations. Up next, I have x over 8. Now, that's a fraction, is greater than negative 5. Well, x over fraction bar, remember that means to divide, and I undo division with multiplication. So I'm going to multiply by 8, and I'm going to multiply by 8. 8 divided by 8 is 1, so we still have x. Greater than, bring the symbol straight down. I have a negative 5 times 8. Well, negative 5 times 8 is negative 40. Now you might be thinking, it's negative, do we need to reverse the symbol? The answer is no, because we multiplied by positive 8. If we have mathematicians multiply by a positive number or divide by a positive number, we do not reverse the symbol. So let's look at the next one. Negative 7y is less than or equal to negative 35. Solving for y, attached to y is negative 7. We undo that multiplication with division. Now stop and pause. We just divided by a negative. So this time we're going to reverse the symbol. Negative 7 divided by negative 7 is 1. So y is no longer less than or equal to, it's now greater than or equal to. Negative 35 divided by negative 7 is positive 5. So y is greater than or equal to 5. Okay, in my next example, I have negative 24 is greater than or equal to 3x. Well, I'm going to go ahead and divide both sides by 3, right? Because the 3 and the x are multiplied. Now I'm dividing by a positive, so I'm not reversing anything yet. I have negative 8. Negative 24 divided by 3 is negative 8. Bring down the symbol, greater than or equal to. 3 divided by 3 is 1, so drop that x down. Now we're not quite finished. X is on the wrong side. It needs to be on the left. So we're going to flip, 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 reverse. Flip, flip, reverse. So x is actually less than or equal to negative 8. All right, one step. I have 2 is less than x divided by negative 3. That's what a fraction means. I undo divided by multiplying. So I'm going to multiply both sides by that negative 3. Now, as a mathematician, I just multiplied by a negative. So I'm going to need to reverse the symbol. Negative 3 times 2 is negative 6. Reverse. Then I still have an x on the right-hand side. Now wait a second, the x is now on the wrong side. We need it on the left. So we're going to go ahead and flip, flip, reverse. So my final answer here, my final solution set is x is less than negative 6. So one-step inequalities is simply using what you already know about equations. Just remember, when we multiply or divide by a negative, as a mathematician, we reverse the symbol. We also reverse the symbol if we need to put the x on the left. We flip, flip, reverse.